Hi everyone, and welcome back. Today we're going to explore one of the most important tools you'll use throughout your SQL journey, SQL Server Management Studio, or simply SSMS. Before we begin, let me give you a small practical tip that has saved me from many unnecessary headaches over the years. Whenever possible, launch SQL Server Management Studio as an administrator. For everyday querying, it may not make much difference, but when you're restoring databases, attaching database files, importing backups, or performing administrative tasks, running as administrator helps avoid many permission-related issues. It's a simple habit, but a good one to build from the beginning. Now, think of SSMS as the control room of SQL Server. If Visual Studio is where we write X++ code, SSMS is where we explore, understand, and communicate directly with the database. Whenever developers want to inspect data, write SQL queries, analyze execution plans, investigate slow queries, inspect indexes, or troubleshoot production issues, this is the tool they open. Whether you're working with Dynamics 365 Finance and Operations, ASP.NET applications, banking software, e-commerce platforms, or almost any enterprise application, chances are there's a SQL Server database sitting behind it, and SSMS is one of the primary tools used to interact with it. Here's an interesting fact. SQL Server doesn't know what a sales order is. It doesn't know what a customer is. It doesn't know what an invoice is. To SQL Server, everything is simply rows, columns, pages, and indexes. It's the application that gives meaning to that data. I always find that fascinating because once you start thinking like SQL Server, writing better queries becomes much easier. Now, let's connect to our SQL Server. Once connected, you'll notice several folders and databases inside Object Explorer. Object Explorer is very similar to Windows Explorer. Instead of organizing files and folders, it organizes databases and all the objects inside them. For developers coming from Dynamics 365, you can think of Object Explorer as being somewhat similar to Application Explorer in Visual Studio. Everything is organized in a tree structure, making navigation simple and intuitive. The database we'll be working with is called AXDB. AXDB is the primary business database used by Dynamics 365 Finance and Operations. Almost every transaction that happens inside D365FO eventually ends up here. Whenever users create customers, vendors, sales orders, purchase orders, production orders, inventory journals, or financial journals, the information is ultimately stored inside this database. This is where SQL Server actually stores the business data. Remember something important. X++ never talks directly to the database. When your X++ code executes a select statement, the Application Object Server, or AOS, translates that statement into SQL. That SQL query is then sent to SQL Server. SQL Server retrieves the requested data from AXDB and sends the results back to the AOS. Finally, the AOS sends the information back to the user interface. So, although developers spend most of their day writing X++ code, the actual data lives here, inside AXDB. Now let's expand the AXDB database. You'll notice many folders like tables, views, programmability, security, synonyms, and several others. Don't worry about all of these right now. Throughout this series, we'll gradually explore the ones that matter. For now, our primary focus will be the Tables folder. This is where the actual business data is stored. Let's open one of the most frequently used tables in Dynamics 365 Finance and Operations, the Sales Line table. If you've ever created a sales order with multiple lines, every single line eventually becomes one record inside this table. That's why Sales Line is such a great table for learning SQL concepts. It's large enough to demonstrate real-world behavior while still being familiar to most D365 developers. Now let's expand the sales line table. The first folder you'll notice is Columns. As the name suggests, this contains every column stored in the table. Fields like Sales ID, Item ID, InventDim ID, Line Num, Sales Text, Delivery Date, and many others are all defined here. If you've worked with the sales line table inside X++, many of these field names will already look familiar. The difference is that here we're looking at how SQL Server sees the table rather than how X++ sees it. Next, you'll see keys and constraints. These help SQL Server maintain the integrity of the data. For example, they ensure uniqueness where required and enforce relationships between different tables. You may also notice a triggers folder. SQL Server supports triggers as a way of automatically executing logic whenever data changes. However, in Dynamics 365 Finance and Operations, Microsoft keeps almost all business logic inside X++ instead of SQL triggers. This keeps business logic centralized and easier to maintain. Now, let's move to one of the most important folders in this entire series, indexes. Take a moment and look at the number of indexes available on the sales line table. There are quite a few, and that's completely normal. Large enterprise tables often have many indexes because different business processes search the same table in different ways. Some queries search using Sales ID, others search using Item ID, some use InventDim ID. Others may search using delivery status, reservation information, project references, or many other business fields. Each of these indexes exists to make a particular type of search faster. Think about a library. A library doesn't organize books in only one way. You can search by title, you can search by author, you can search by category, you can search by ISBN. Indexes work in a very similar way. They're simply different paths that help SQL Server locate information more efficiently. Now look closely at the list. Almost every index is marked as non-clustered, but one of them is marked as clustered. This is the clustered index for the sales line table. Remember what we learned earlier. A table can have only one clustered index because the data itself can only be physically arranged in one order. Every other index shown here is a non-clustered index. These indexes don't contain another copy of the table. Instead, they maintain a separate B-tree structure that stores indexed values along with pointers that tell SQL Server where the actual rows are located. Hopefully, you're now beginning to connect all the concepts we've learned so far. Pages, indexes, B-trees. They're no longer just diagrams. You're looking at the actual implementation inside a real SQL Server database. If you scroll a little further down, you'll notice another folder called Statistics. Statistics are one of SQL Server's most powerful features. Think of them as the database's memory. Instead of remembering where every row is stored, SQL Server remembers information about how data is distributed. Using that information, SQL Server can estimate how many rows a query is likely to return and choose an efficient execution strategy. We'll explore statistics in much greater detail later in this series because they're a fundamental part of how the query optimizer works. Before we finish, here's another small SQL tip. Whenever you're learning a new database, don't jump straight into writing complex queries. Spend a few minutes simply exploring the database structure. Open tables, expand folders, look at columns, read index names. Try to understand how the database has been designed. The better you understand the structure, the easier it becomes to write efficient SQL queries. I still do this whenever I start working on a new project. Even after years of experience, the first thing I do is explore the database. It tells me a surprising amount about how the application has been built. Today wasn't about writing SQL. It wasn't about optimization either. It was about becoming comfortable inside SQL Server Management Studio and understanding where everything lives. From this point onward, whenever we discuss indexes, pages, execution plans, statistics, or performance tuning, you'll know exactly where to find those objects inside SQL Server. And that's a skill every SQL developer should have, regardless of the application they're working on.